Okay, checking your work. The first one has two different slopes, 2 for the first equation and then a minus 1 or a negative 1 for our second equation here. So that's going to give us exactly one solution since the slopes are different. Part B, I rearranged those equations to get y equals mx plus b form so I could compare slopes, and I noticed right away that my slopes are the same. Sorry, a positive 2/3 and a positive 2/3. But then we have different y-intercepts. So those are going to be parallel but distinct lines. Those will have no solutions to them. No solution to that system. Part C, again, I rearranged in the form y equals mx plus b, and I found that my slopes were different. Positive 4x versus a negative 4x. So positive 4 is a slope and negative 4 is a slope. That's going to have one solution. And then when I check my next one, rearrange them in the form y equals mx plus b, I found that they were the exact same line. And we know if the two lines are exactly the same, they lie on top of each other, and there's an infinite number of solutions. That's an apostrophe. All right, number 2, express the following in the form y equals mx plus b. I got y equals 3 take away 3/2 x, or I could flip that around and have y equals, just try that, y equals negative 3/2 x plus 3. It doesn't really matter the order of these, but generally we write things in descending powers of x, and we're used to saying y equals mx plus b. The second one, you were to replace that plus sign with an equal sign because I goofed. And we end up with y equals 9/4 x, take away 7/4. And you could take those to decimals. I tend to leave them in fraction form. Okay, check the next one. Okay, when you graph these ones, there is one intersection point, and it's somewhere down here. But if you look, I'm just going to undo that drawing there. I have that the top one, the blue one, it passes through the point 1 and -2, and the red one passes through the point -1 and positive 1 and -3. So the intersection point happens slightly before when x is equal to 1. So I'd have to estimate from this. It's really hard to tell from the graph what exactly our intersection point is. Now you could go into Desmos, it will give you an exact value, but I'm going to guess that it's like 0.9-ish, and then I could sub that in and find my matching y value, which should be about negative 2.5-ish. I'm just putting that into my calculator right now, and then I subtract 4. It came out with actually negative 2.2 as an answer on that one. Okay, so this is approximately equal to. That's an approximately equal to sign, or you might be more familiar with approximately equal with a dot. That would be the solution potentially for this. But until we check it with technology, we don't really have a method to do it. That's where our algebraic methods can come in handy. So if I were to actually use my algebra skills, I can learn how I can make this work, or how I can find the intersection point, and that's going to come up in the next video.